In this video, we will be going through inverse trigonometric functions. And we will talk about inverse of sine function, inverse of cosine function, and inverse of tangent function. The inverse sine function. If y equals to sine inverse x, or y is equal to arc sine x, if and only if sine y equals to x, where y is the angle. So what we are saying is y is sine inverse x if sine of y is equal to x. Now the x is the domain, and the domain has to be between -1 and +1, like this one. And the range is from -π/2 to +π/2. And for this domain and range, arc sine of sine y is equal to y, so they cancel out. For y has to be in this interval π/2 and π/2. Similarly, sine of arc sine x will be x for every x in the domain -1 to +1. Inverse cosine of x. Y equal to cosine inverse x, or y equal to arc cosine x, if and only if cosine of y is equal to x, where y is an angle. So again, x is between here -1 to +1, and y has to be between 0 and pi, just like shown in this picture. So these are -1 to 1, that's the domain, and from 0 to pi, that's the range. And for this domain and range, arc cosine x of cosine y is y, and cosine of arc cosine x is x. Okay, the inverse of tangent of x. The inverse of tangent x we write as tangent inverse x. And if this equals to y, or we can write y arc tangent of x. So some people write tangent inverse x, then we write arc tangent. So you can write any. This is the inverse function. Now y is arc tangent x if and only if tangent of y is equal to x. So arc tangent x is actually an angle. Okay? Is an angle whose tangent is x. So the domain here is x is all real numbers from -infinity to infinity, but the range is from -π/2 to +π/2. For y in this range, arc tangent of tangent of y is y, and for x in this domain -infinity to infinity, tangent of arc tangent x is just an x. So example 1. Find the exact value of arc sine of square root of -2, with negative sign here. So let's see. So let y is equal to arc sine of -square root of 2. Okay. Now, and then we can write sine of y equal to -square root of 2. But y has to be in between -π/2 and +π/2. So from the table, we can see that when y is π/4, sine π/4 is square root of 2/2. So therefore, when sine y is a negative square root of 2/2, then y must be -π/4. Not 3π/4, which is here, and just whose sign is this one, because 3π/4 is outside this interval. So it's not in this domain. So therefore, in this case, the answer would be -π/4 and not 3π/4. Now find the exact value of arc cosine of -1/2. So we can do the same thing. Let's start with y equals to r cosine of 1 over 2 with negative sign here. So then by definition we can rewrite cosine of y equals to negative 1 over 2. And now y has to be in this interval 0 to pi. So now let's go to the table and we can see we look for negative 1 over 2 in this row cosine is right here. And the angle we go up, the angle is 2 pi over 3. And let's check if 2 pi over 3 in the interval. Yes, it is. So in this case, the answer will be 2 pi over 3. So example 4. We're going to find or evaluate arc tangent of negative 3 using calculator. So let's say Texas Instrument, for example, 84, 83, work the same way. So first thing you do, you change the mode to radians. Then press second and then press 10. You will see the calculator, you will see on the tangent minus 1 here, which is a tangent inverse. Now you import minus 3 and close the parentheses and then press enter. You should get negative 1.2490 and then round to 2 decimal places, negative 1.25 or whatever the web assign tells you to round. Okay? Example 5. So we're going to evaluate arc sine of negative 0.75. Okay, so we're going to use, let's say, T84, or you can any Texas Instrument. Again, make sure the mode is in radians. Press second, press in, SIN, and you should see sine inverse. And then input minus 7.5 and close the parentheses and then press enter. You should get negative 0.84806. Round to 2 decimal places should be negative 0.85. So example 6, inverse function and calculator. Let's evaluate arc cosine negative 0.41 using calculator. So let's see, change the mode to radian, then press second, press cosine. You will see on the calculator cosine inverse parentheses, input negative 0.41, close the parentheses. Once you have this, press enter. And you get 1.99325, down to 2 decimal places become 1.99. So we're going to write this time inverse tangent function to write theta as a function of x. So this is the triangle. As you can see, angle theta, and 7 is the base and x is the height. We don't need to complete this triangle. In other words, you don't need to find the missing side. All you have to do is just take the ratio of x and 7. So we write x over 7 and x is opposite and 7 is adjacent, and we know opposite of adjacent is tangent. So you have x over 7 equal to tangent theta, or tangent theta equals x over 7. Then, but inverse property says theta would be, take the tangent on the side and write arc tangent of x over 7, or tangent inverse x over 7. So what this triangle whose adjacent side is x plus 1, hypotenuse is x plus 2. So again, we don't need to find this one. So you just take the ratio of these two, x plus 1 or x plus 2. And now x plus 1 is adjacent, x plus 2 is hypotenuse. You have to know adjacent of hypotenuse cosine theta. Okay? So you can rewrite cosine theta equal to x plus 1 or x plus 2. Now, take the cosine to the other side and leave theta as, then write here arc cosine of this x plus 1 or x plus 2. So that's all you have to do. Writing theta as a function of x. So we're going to write an algebraic expression that is equivalent to tangent of arc cosine x over 5. So let's call theta equals to whatever you have. So in this kind of question, so you have to use r cosine x or 5 theta. Okay, then if this is theta, so this whole thing becomes what? Tangent x, r cosine x of 5 becomes tangent theta. And we have to find tangent theta using theta equals to r cosine x over 5. Now this you have to rewrite. Take the cosine this side, make a cosine theta equals to x over 5. And assign, let's make a triangle and assign adjacent equals to x here, and the hypotenuse we assign 5, and then we calculate the opposite side using this formula. Opposite square of opposite is square of hypotenuse minus square of adjacent. It's just like this is b and this is a. So we're looking for a, so a would be c squared minus a squared. Okay, it's like that one. Now hypotenuse is 5, so it's 5 squared, and adjacent is x, become x squared. Take the square root, so we can opposite equal to square root of 25 minus x squared. So opposite is this one. Now from this triangle, we can find tangent, and we know tangent theta is opposite of adjacent. So which is square root of 25 minus x squared over x. So that's the answer. Example 12. An airplane flies an altitude of 6 miles over this observer. So theta and x are shown. This is theta and that's the x. So x is the distance of the plane from the observer. So we have to write theta as a function of x. So you can see this is opposite is 6 and adjacent, and this is hypotenuse is x, and opposite over hypotenuse is equal to 6 over x, and that is sine theta. So sine theta is 6 over x. Now it's using inverse property, you take the sine to the other side, make an arc sine. So theta equal to arc sine 6 over x. And that's the answer to this. Write theta as a function of x. And next we're going to part B, we're going to find theta when x is 12. So we substitute x equals to 12 in the equation we just found, theta equals to arc sine 6 over x. So this becomes arc sine 6 over 12, simplify arc sine 1 over 2. Now you put this on the calculator or the table, try to find angle 30 degrees. And that's the end of this section.